Selamat datang di media pembelajaran Tata Surya. Tata Surya adalah sistem antariksa yang saling terikat gravitasi, di mana terdapat matahari dan benda-benda langit yang mengitarinya secara langsung maupun tidak langsung. Dari sekian banyak benda langit yang mengitari matahari secara langsung, terdapat benda langit yang paling besar yang dinamakan dengan planet. Planet adalah benda langit yang mengelilingi bintang sebagai pusat tata surya. Planet tidak dapat menghasilkan cahaya sendiri, namun dapat memantulkan cahaya. Planet yang dekat dengan bumi dapat kita lihat setiap hari dengan mata telanjang, seperti planet Venus yang disebut orang sebagai bintang fajar. Matahari, bumi, Saturnus, Merkurius, Mars, Uranus, Venus, Jupiter, Neptunus.
Lapisan-lapisan utama matahari. Matahari terdiri dari beragam gas, terutama hidrogen. Batas di antara lapisan gas yang berbeda suhu dan kerapatan adalah tidak jelas. Namun demikian, 4 lapisan zat penyusun matahari dapat dikenali. Korona merupakan lapisan terluar dari atmosfer matahari. Terdiri dari partikel-partikel gas yang tersebar pada wilayah yang sangat luas, sehingga kerapatannya sangat rendah. Namun demikian, suhu partikel-partikel gas ini dapat mencapai 1,7 juta derajat Celcius. Kromosfer. Lapisan setelah korona adalah kromosfer, yang merupakan lapisan tengah atmosfer matahari. Tebalnya mencapai ribuan kilometer. Kadang-kadang, gas-gas di kromosfer tiba-tiba menyembur keluar sejauh 16.000 km. Suhu rata-rata kromosfer adalah 27,8 ribu derajat Celcius. Fotosfer. Lapisan terdalam dari atmosfer matahari adalah fotosfer. Tebal fotosfer sekitar 550 km dan sering dianggap sebagai permukaan matahari. Suhu fotosfer sekitar 6.000 derajat Celcius. Bagian ini merupakan bagian dari matahari yang memberikan energi panas dan cahaya kepada kita. Inti. Bagian utama massa matahari dinamai inti. Di batas permukaan inti, yaitu di dekat fotosfer, suhunya mencapai 1 juta derajat Celcius. Sementara di pusat inti, suhunya dapat mencapai 15 juta derajat Celcius. Suhu yang sangat tinggi ini dihasilkan oleh reaksi fusi hidrogen yang berubah menjadi gas helium. Dan perubahan ini membebaskan energi yang sangat besar.
Mysteries. Mercury is the smallest planet in our solar system. Its diameter currently measures just over 3,000 miles, about the size of the continental United States. Like Earth, Mercury is a terrestrial planet with 3 main layers: a core, a mantle, and a crust. Only Mercury's crust has no tectonic plates. Also, its iron core is enormous by comparison, making up 85% of its radius, while Earth's inner and outer core account for just 55%. Because of the core's exceptional size, it's had a surprising influence on Mercury's overall size by causing it to shrink. The hot iron core has slowly cooled and contracted over the planet's 4.5 billion years. In doing so, it pulled Mercury's surface inward and has caused the planet to shrink radially by more than 4 miles. This shrinking planet is also the planet closest to the Sun, orbiting our solar system star at an average distance of roughly 36 million miles. Such proximity affects Mercury's atmosphere, or rather, the lack of one. It only has a very thin exosphere, which is traditionally the outermost layer of a planet's atmosphere. This exosphere is made of oxygen, sodium, hydrogen, helium, and potassium, all whipped up from the planet's surface by solar winds. The lack of atmosphere and close proximity to the sun also makes Mercury a planet of extremes. The surface temperature can climb to 800 degrees Fahrenheit during the daytime and fall to 290 degrees below zero at night. Mercury's proximity to the sun is also the reason behind its age-old reputation of being swift and fleeting. The sun's gravity pulls harder on Mercury than any other planet, and like all planets, Mercury travels in an elliptical orbit, slowing down when it's farther away from the sun and accelerating as it draws closer. Clocking in at an average speed of over 100,000 miles per hour, Mercury slings around the sun in just 88 days. From Earth, Mercury is difficult to observe because it's fleeting and so close to the sun. And so far, it's only been visited by 2 spacecraft, NASA's Mariner 10 and Messenger. Those missions gave us much of what we know today, but future ventures are in the works with high hopes of revealing more of Mercury's secrets. But behind this facade is a world of storms and infernos unlike anywhere else in the solar system. Venus, the second planet from the sun, is very similar to Earth from a distance, but up close, it's a very different world. Venus is about the same size as Earth, just slightly smaller. Its structure is also nearly identical, with an iron core, a hot mantle, and a rocky crust. The crust of Venus, however, is dotted with thousands of volcanoes, including Maxwell Montes, a volcano almost as tall as Mount Everest. Venus also has a thick, layered atmosphere. It's full of clouds that rain sulfuric acid and whip around the planet at speeds up to 224 miles per hour, faster than some Category 5 hurricanes. The atmosphere is so thick that it creates a surface pressure similar to what it would be about half a mile deep in the Earth's oceans. This pressure is heavy enough that a human standing on Venus's surface would be crushed. The atmosphere is made of greenhouse gases, primarily carbon dioxide, which create an extreme case of global warming. They trap the sun's heat, causing surface temperatures to rise over 880 degrees Fahrenheit, making Venus the hottest planet in the solar system. Venus is so inhospitable, neither humans nor spacecraft are able to survive the planet's surface. But some scientists speculate that Venus wasn't always so unwelcoming. From roughly 2.9 billion to 715 million years ago, global temperatures on Venus may have been just a few degrees cooler than Earth's are today. And scientists theorize that the surface may have contained shallow oceans that could have held enough water to support life. Today, life may still exist in Venus's atmosphere. About 30 miles up in Venus's clouds, where the temperature and surface pressure are similar to those on the surface of Earth, scientists have observed strange dark streaks that appear to be absorbing ultraviolet radiation, a phenomenon that could be evidence of microbial life. Life may struggle to survive in the atmosphere of Venus, but it is this unforgiving environment that's made Venus an icon of beauty. It reflects 70% of all the sunlight that reaches the planet, which is why Venus shines more brightly than any other planet or star in the night sky. While more than 40 unmanned spacecraft have visited this infernal world, Venus, so illuminated in the darkness of space, still has much to reveal. Our very existence. Approximately 4.5 billion years ago, the Earth formed from particles left over from the creation of our sun. gravity drew these particles together to form pebbles, which then formed boulders and eventually the Earth. At its heart is a solid inner core covered by a liquid outer core. Above this sits the mantle made of flowing silicate rocks and a rocky crust. This rocky mass is the third planet from the Sun, orbiting the star from an average distance of about 93 million miles. It's close enough to the Sun to be warm, unlike the cold gas giants, but not so close that its surface is exposed to extreme heat and solar radiation, as is the case with Mercury. Earth's unique position in the solar system allows it to house phenomena yet to be found anywhere else in the universe, particularly liquid surface water and life. According to one theory, much of Earth's water is as old as its rocks, both of which having formed during the Earth's earliest days. Because of Earth's unique distance from the Sun, the planet is able to contain water in all of its forms, liquid, ice, and gas, rather than have them permanently frozen or evaporated into space. But Earth is the only known place in the universe with liquid water on the surface, thereby having unique cascading effects on the planet. It hydrates the land, helping create nutrient-rich soil. It collects and pools to form oceans and freshwater systems. And it cycles upward to add moisture to Earth's protective atmosphere. And where there is liquid water, there is life. About 3.8 billion years ago in Earth's oceans, primitive life existed in the form of microbial organisms. For a bright new future for humanity. The story of Mars began about 4.5 billion years ago when gas and dust swirled together to form the fourth planet from the Sun. Mars is the second smallest planet in the solar system, with a diameter just shy of the width of Africa. In fact, its entire surface area is similar to that of all of Earth's continents combined. Much like its terrestrial cousin, Mars is dense and has a rocky composition. At the center of the planet is a core made of iron, nickel, and sulfur, which may have created a protective magnetic field during Mars's earlier years. Enveloping the core is a rocky mantle made of silicate minerals and a crust rich in iron. These iron minerals react with the trace amounts of oxygen in Mars's atmosphere and rusts, giving the planet its signature reddish hue. While its blood-like appearance inspired the ancient Romans to name Mars after their god of war, the planet's rusty color could be considered symbolic of the planet's prime days long past. Today, Mars is dry, desolate, and cold, with temperatures dropping as low as negative 225 degrees Fahrenheit. But billions of years ago, the planet was much warmer, more geologically active, and had a watery surface. Lake beds and river valleys snake along the face of Mars, indicating that liquid water was, for a time, present. Volcanoes, such as Olympus Mons, the largest volcano in the solar system at 3 times the height of Mount Everest, once erupted lava. But by about 50 million years ago, soon after Earth's dinosaurs died out, Mars's volcanoes also went extinct. Water on the red planet still exists today, but mostly in the form of polar ice caps. Because of factors such as the presence of water, some scientists believe life may have existed on the red planet, and may exist again. Since the 1960s, space programs from around the world have launched missions to Mars in attempts to understand the planet's past, present, and potential for sustaining life. Life on another planet may well be out of reach for the near future. But if any planet could give us hope, Mars may hold the key to the survival of humanity.
The giant. Jupiter, largest planet in the solar system. So let's get the obvious question out of the way. How big is it?
Analyzing.
This is Earth. This is Earth compared to Jupiter. It would take more than 1,000 Earths to fill the fifth planet. But our journey today fixes a bullseye on Jupiter.
Referencing data index. Telemetry archive online.
Most of the images you'll see come from various spacecraft that made the trip.
Data now available.
For example, Voyager 2 collected this remarkable sequence in 1979. Movies of Jupiter are exceedingly rare.
Approaching periapsis.
Most visiting spacecraft simply use Jupiter's immense gravity as a slingshot for journeys elsewhere.
Low gain antenna online. Spectral analysis complete.
Churning skies of roiling clouds compel the attention of even casual visitors. Jupiter's face is an opaque, seething mask, ever-changing, revealing nothing of the small, dense core tens of thousands of miles below.
Hydrogen-helium atmosphere.
The planet's extraordinary rotation speed keeps the grinding sky in constant motion. The huge planet makes a complete revolution in just 10 hours,
Enhancing image.
compared to 24 on our little Earth. Winds howl constantly at almost 300 miles per hour.
Vector analysis.
With that much wind, strange things are bound to blow around.
Atmospheric anomaly detected.
Like this, the famous red spot. The red spot is a rotating high-pressure system. Weather, in other words. And it's a storm that's been churning for well over 100 years, likely observed in even the earliest telescopic observations of the planet. Just like our own planet, Jupiter changes every day.
Saturn is quite a planetary gem. Saturn is the second largest of the 8 planets, and it is about 10 times as wide as Earth. Despite its size, Saturn is actually the lightest planet. It is predominantly made of the gases hydrogen and helium, and because of its particular gaseous composition, Saturn is the only planet in the solar system that's less dense than water. If the planet were placed on an enormous ocean, it would be able to float. Saturn's gaseous makeup also means that it has no true surface. At its center, the planet has a dense core of water, ice, and rocky material, but it has no actual landmass. Instead, it's mostly made of gases, liquids, and yellow ammonia crystals that swirl around the planet, creating golden clouds and storms. The largest storm on Saturn is at its North Pole. It's over twice the size of Earth and shaped in a near-perfect hexagon. Each of the 6 sides is believed to be the result of jet streams, which all encircle a massive hurricane. Because of Saturn's inhospitable environment, the planet cannot support life, but some of its moons might. Saturn has more than 50 confirmed moons, and each varies in size and terrain. Enceladus, one of Saturn's smallest moons, is covered in ice and only about as wide as the state of Pennsylvania. Titan, Saturn's largest moon, is nearly as wide as Canada. Titan is also the only moon in the solar system with clouds and a dense atmosphere. Both Titan and Enceladus have underground oceans that would make them potentially capable of sustaining life. Saturn's moons may also play a role in shaping the planet's signature feature, its rings. Saturn's ring system is the largest and most complex in the entire solar system. The rings are made of icy and rocky remnants from comets, asteroids, and moons. The particles range in size from being as small as dust to as big as mountains. The ring system is divided into 7 groups of rings. Altogether, they are as wide as 4.5 Earths, but only about 2/3 of a mile thick. How the rings are able to stay on track and intact has to do with Saturn's smallest.
63 times larger than the Earth. Here, you'd be lucky to celebrate a single birthday. The planet takes 84 years to make its way around the Sun. Uranus and sister Neptune are known as the ice giants because of their frigid outer atmospheres, supercooled to minus 355 degrees Fahrenheit. But the biggest, most obvious feature about Uranus is its crazy tilt. However, it wasn't always this way.
The traditional explanation was that while Uranus was forming, it may have been hit by a larger chunk of accreting material than normal and actually knocked it over on its side. The problem is when you do the maths on this, it doesn't work. It's very, very difficult to get a large enough body traveling fast enough to be very credible at knocking Uranus over on its side.
Rather than being pounded, it's now thought that Uranus may have been swept off its feet by the gravitational tugs of its giant neighbors.
Uranus's tilt actually results from rather complicated interactions with Saturn, Neptune, and Jupiter even. All of these planets do have gravitational effects on one another, and the effects are more subtle than we used to think, and it's dynamics, not a big smack in the face from a large impacting planetesimal.
Imagine if Earth were like this, tilted on its side. Equatorial jungles would turn to ice. In summer, the Arctic Circle would evaporate and become a steaming tropical paradise. What would be north? What would be south?
You can get into very long, heated discussions at a bar with astronomers about what the North Pole of Uranus is. So don't go there.
If tilting the Earth causes weather chaos, what is it like on Uranus? Do the clouds spin on the same axis as its tilt, or differently? Scientists have many questions about the first ice giant. When Voyager journeys to the outer solar system in the 1970s, it beams back astounding images of Jupiter, Saturn, and many of their moons. At 30 times the distance of the Earth to the Sun, the star appears not much more than a glimmering point of light. Out here, the days pass quickly, each 16 Earth hours long. But you'll need a thick calendar with around 90,000 days to a Neptunian year. That's 165 Earth years to orbit the Sun. Like its neighbor, Neptune is a giant ball of hydrogen and helium, its color courtesy of a bit of methane. But it's so blue here that some other chemical mixture is at work.
In fact, there's something in the clouds of Neptune that is causing its vivid blue color, and we don't know what that is yet. It's one of the mysteries that we're trying to solve by studying Neptune with our telescopes on the ground and in space.
There's a little bit less scattering in the atmosphere. There's a deeper methane layer, so even more of the red is absorbed out of the atmosphere. It makes Neptune really a blue planet instead of a green planet.
And that's not the only mystery. Something is driving Neptune's wild winds, the fastest in the solar system. And why do Neptune's spots vanish almost as quickly as they appear? Most amazing of all, Moon Triton has a secret that has all the experts wondering.
So as we were approaching Neptune and it was getting larger and larger in the TV screens in the Voyager project area, the thing that really got us going very rapidly, we noticed that Neptune had something that Uranus didn't, which was a big spot in its atmosphere.
Voyager saw several spots. One of them, the biggest one, we imaginatively called the Great Dark Spot.
It kind of was like watching a blob of ink in swirling water.
About the size of Earth, the Great Dark Spot is actually a massive hole, a window to the darker clouds below.
Banyak para ahli berpendapat bahwa komet ialah serpihan-serpihan dari tata surya yang terbentuk 4,6 miliar tahun yang lalu. Diperkirakan ada lebih dari 1.000 buah komet yang melintas dekat dengan matahari dalam setiap abad. Dari jumlah tersebut, hanya sedikit komet yang cukup terang yang sehingga bisa dilihat dengan mata telanjang. Yang pertama, nukleus atau inti nukleus atau inti adalah pusat yang sangat terang pada sebuah kepala komet. Inti tersebut bisa mencapai 100 hingga 10.000 meter. Diameter komet Halley ini terkira sebesar 5.000 meter. Ahli astronomi beranggapan bahwa nukleus komet ini berupa bola salju kotor.
More than 4 billion space bodies, aka meteoroids, fall into the Earth's gravity well every day. This moniker covers everything in size greater than interplanetary dust, but less than that of an asteroid. These are small stones in the majority, which quickly burn up in the terrestrial atmosphere. Only a few can pass this barrier. Meteoroids that reach the Earth's surface are then called meteorites. At the same time, they do not pose a particular danger, although occasionally they can make local residents nervous, as happened recently in Chelyabinsk. But what if we increase the velocity of the meteorite to the speed of light? No particle with mass is actually capable of the speed of light, but in fact, for our purposes, we don't need it. It will be enough simply to approach this speed, just a little, such that the entire solar system will be in shock. But let's do this in the proper order. Imagine that we have a round diamond ball 30 meters in diameter, and we have just launched it in the direction of the Earth at a speed of 3,000 kilometers a second. First of all, it should be noted that the air in our atmosphere begins to participate in nuclear fusion at such velocities. And with this plasma heating, the process might be able to destroy our diamond sphere entirely before it reached the Earth's surface. But the Earth will not get the better of us. This sphere will not fly wide enough and at some point will crash into the Earth.
Dan untuk kalian semua yang menyukai video ini, jangan lupa like, comment, share, dan subscribe.